Alright. Cool. Hi. Hello. Good morning. Or evening. It's good time of day. Good time of day. Let's get into this, shall we? So, I don't really know. I'm a little bit curious. For one, I want to test out my particular stuff, so let's go into here and do a little bit of access more tools in mod view. I don't care. Let's do a little bit of coffee.
I need more caffeine. My blood is nothing.
Interesting. I know what I need to do. I need to... What the hell? So I need to have the desktop audio? That's interesting. I don't know if I like that. Okay, okay. So I need to have the desktop audio. Which actually means that the music is being captured twice. Which I really don't like. I don't know. I'll have to think about something. I don't know. Whatever. I'll have to look into it and figure it out. No, but anyway, so what do we have here? We have so what is the goal? my blood is not thin enough. This shit. So, my blood is not thin enough. Well, so we have. And I also don't think that I have a very good tester. Because there's. So there is a. There's the gain. There's the pre-boost. Right? We have to have a gain. We have to have the temperature remap. The gain, the temperature remap. There's also a because there's like the white balance, right? And the white balance is a little bit strange. Because what I want to do is I want to make it because there's like a weird there's like a hue shift thing that you can do. Because there's like there's a color space that like no one uses. It's like super easy to do. It's basically just changing it to be along the it's just changing it to be along one of the there's like an orthogonal base along the diagonal, and it's I could derive it, right? Because the brightness is along the 111 axis. I forget how to do the how to do like the change basis. I could look it up. Alright. Because there's like a certain way of handling like change of basis and things like that, right? Because the basis vectors are I think you just list out the basis vectors. Right? Yeah. Because it's like 111 but because it is a color space that goes from it's a color space that goes from 0 to 1 to -1 to 1, right? The brightness goes from like brightness 0, or I should say, what is it? It's not necessarily a brightness or luminance. It's more like a gray shift, right? Because gray shift 1 is white, gray shift -1 is black, and gray shift 0 is just normal 50% gray. Right. And this -1 to 1 color space is really, really nice because it's like a boost versus yeah, it's like a boost versus a yeah, because yeah, it's just a different color space. So you know there are 3 individual sliders. There's well, I mean, and there's also the gamut at the very end. So let's do a little bit of looking up of change of basis. Change of basis vectors matrices. Yeah. The 1 becomes the standard basis ij to a new basis uw. And the new vectors are u prime equals and w prime -1. Okay. Yeah. Gotcha. Alright. So to convert from old to new. Okay. So yeah. Let's bust out. Let's bust out the good shit, huh? Alright. Alright. So let's bust out the good shit and do a thing. So we have a color space of R. That's not an R. That's not R. We have R G B, right? RGB. And we want to, and then this kind of fills out a cube, right? Now, we want to convert from old to new. So the new one is effectively from here. We have a vector. We have that one. We have that one. And then we have the cross product. Kind of, sort of. Because it is from the center of this cube. So it starts at, so O is equal to 0.5, 0. Let's do this properly, shall we? Yeah, it's 0.5, 0.5, 0.5. Right, that's the origin. That's the origin. Right. The gray gr is equal to in the old space is equal to 1, 1, 1. Right. We have B is equal to 0, 1, 0. And then what the fuck is a cross product of? What is a cross product of these two things? Yeah, because I think it's G cross D. Yeah. And I forget how to do it. Because it is it is actually over here, right? Because you're kind of looking at it from the side. So I think it ends up being something along the lines of T is equal to red is 1, G 0.5, B 0, right? I think that's what it is. Yeah, that looks about right. So we have, BDT. Or some such stuff. Because it's not quite saturation, but I mean, it's pretty close to saturation. It's just it's gray. It's whether or not it's positive or negative gradients. It's a G. It's GDT, right? Yeah, it's just GDT. Like, that's just what it is. Right. So we have, GDT, right? This color space. And then I think the inverse of it. Right, so I mean, it just depends on what order it is, right? You literally take these three vectors and you split it up, right? So to convert from that to the new one, it's literally just 1, 1, 1, 1, or 0, 1, 0. 0, 1, 0, and then it is 1, 0.5, times GDT DDT is equal to RGD, right? And then the other way, you literally take the inverse of that, which we can say, what are each of these, right? And you can map this shit out, right? Or you can just take the inverse of that. Which is what I'm going to do. I'm going to find the inverse matrix of that real quick. Inverse matrix calculator, inverse matrix for Reshish. This is actually a 3 set matrix. 1. I don't need complex numbers. Thank you very much. 1. Oh, actually 0. 1. 0. 1. 0.5. 0. What do you mean I can't calculate? Hello? Okay, fucking whatever. Cool. So it should be... so to go from GDT to RGB, use this matrix. To go from RGB to GDT, use a different one, which is 0, minus 1, half, 1, 0, 1, 0, 1, minus 1 half, minus 1. So times RGB equal G to DT. Right. That should be it. So what all does this mean? Right? What all does this mean? And let's take a look at the with this one in mind. Let's take a look at that color space again. Alright. So what this is saying is what exactly? From here. So from here to what we're saying is red is 0. GDT 0 gradient. 0 gradient. I would expect red, 100% red to be... Oh yeah, it is 0 gradient. Because, yeah. So red is 0 gradient. So red is what, 0 gradient? So since this is that, yeah, minus 1 half. Yeah, so that is red. RG is just the same as D. And blue is this weirdness, which is 1. Interesting. Fulbright. I mean, I would expect all of them to be GDT. Why is that any different? Because this should be like that's there. Why is that any different? Interesting. Because all 3 of these should be. I would expect it to be. What? Temp. Oh, positive temp is red. Uh-huh. And B is -1. Negative temp. Yeah. No, that actually does make sense. Because it is... Yeah, it's minus temp. How in the fuck is this 1 though? Nani? Is positive? How is it positive gradient? I don't understand how that's positive gradient. I don't get it. How is that positive gradient? I'm just gonna assume that it's correct. Because like it doesn't feel right. Because technically speaking, the gradient should be like a red should also be. How the fuck is it 1? Nani? Nandeo. It should just be. Be the same. It should be the same. Should be the same here. How the fuck is it 1? 1 minus 1 minus half minus 1. Interesting. Yeah, I don't know. But yeah. Yeah, it's the great. There's just some weirdness because blue is still negative. Blue is negative. I mean, gradient is also GDT. Yeah, gradient is that. Means 0 grad. But it's not. It's minus some shit. Nande. 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 Oh, I really don't give a shit about that. Okay. What is it? It should be. Am I doing this right though? That's the real question. Am I actually doing this right? Am I setting this up properly? Is that correct? Is that the correct thing? Is this Is this true? Yeah, it should be a change basis. This is the basis. Green is green is green is green. You just use the 30 basis vectors for each of the different fucking things. GDT. D is green. G is just green. Plus minus green. But Nande. Nande. Because the axis is different. Like, it's crazy different. Why is it like that? Nande. Because green... Green is there. Green is directly... Oh. Nani? Nandale. What the fuck is a D6? Come on, D6. Here's my polyhedra. Am I thinking of this properly? So, from the top... Yeah, from the side, it's not actually correct. It's not the center. That's not the center. Interesting. Okay. Oh. I see why. I see why. I see. Okay. So it's a little bit skewed from what I thought I was doing. And what I actually want to do... I mean, do I want to have that skew, or do I actually want it to be proper? Because this is a color space that could very easily just be... Okay. It's a little bit skewed. Because I could, like, project it and shit, right? Yeah, because, like, the length of things aren't going to be proper either, and things like that, so I think this skew is actually okay. Yeah. So because it's skewed, it's doing that. But why is blue? Okay, so if I have the cube, let's say even is that, alright? So the corner of, okay, so it's that, alright? And then I have, wait, what? Nande. Okay. Nani. So, why one? Neither of those should be one. None of them should be one. They're all negative. Huh? I mean, they're all negative. Is it because of the skew? Oh, there's 0 and shit? I don't know. I don't get it. I don't understand why. Blue. How the fuck is blue positive? How the fuck is red? Okay, red being just straight up temperature makes sense. Positive temperature. How the fuck is blue just that? I don't know. I do not know. So let's there's a bunch of shit here that we could do. So number 1, so we have the color, we have that, right? So let's just get rid of these. All right. We can do uniform. We could do uniform. Because I kind of want. Well, I mean, I could do not any uniforms right now, right? I could do none of them. Okay. So and we don't really know what kind of what kind of thing we want to do. So we don't need a uniform. We could do let's just do Texel. Oh, we don't need any of this garbage, do we? We could do that, right? So what were they? Yeah. So from okay, so if we wanted to do the same and we wanted to get the we wanted to treat the incoming stream as GDT. We feed it through this one. All right. So let's do a little bit of did we do there? So let's do mat 4. Mat 4 RGB RGB to GDT is equal to mat 4. This is a Oh wait, no, it's not a mat 4. It's a mat 3. Mat because it's also mat 3. There we go. Vec 3. It should be all those. 1, 1, 1. Vec 3. 0, 1, 0. Vec 3. 1, 0.5. 0, 1.0. We can do a dot 0, dot 0, dot 0, dot 0. Alright, so we can have that. And then call is equal to vec 4. I mean, I could do RGBA to GDTA. Right. Which is literally just zeros upon the board and just do. I think that would be. I think that would be the better way of doing it. So, yeah, because if I do a mat 4 here, and I do a mat 4 RGBA to GDTA, we can do mat 4, mat 4, mat 4, oh wait, no, we want that there, and then we can do comma vec 4 0.0 0.0 0.0 1.0. No, not there. It's there. Hold. Fucking goddamn. Alright. So what we can do is that's not what I want to do. Clear and dots. Nande. Syntax error. Yeah, okay. Col is equal to RGBA. Yeah, that. Times. I think you could just do that. I don't know if you can or not. Epsilon does not exist. Okay, cool. That's fine. That is correct. That is true. Epsilon does not exist. Correct. Let's save and run. Ooh, pretty. Okay. That I think is correct. I think that is correct. Yeah, looks about right. Oh no, the bottom is blue. And there's way too much white shit. Bottom should be blue. Right. Okay. Because we have negative values and things like that. But what the fuck? Monday. Okay. So that's not quite what we want. So what is black? So RGB, okay, so RGB. Let's think about what each of these should kind of map to, right? So black. So RGB black, 000. Mm-hmm. Oh shit. Because 000 maps to 00 minus 1. Da. That is why blue. Okay, so that's why blue is all fucky. Which means that it needs to be shifted. Swifty. There's an offset. That's why it's so fucking weird. Okay. That's why. Because of the domain space. Right. It is not the basis vectors that's happening. Because the basis vectors themselves are doing some weird shit. Because there is a translation factor. Okay? So it is, we want to do what exactly? So how do we figure that out? Right? It is a translation. So the translation is shift into. Okay. So it is a shift, right? The origin is moved. Right? The origin is moved. There, right? So we want to move that. We want to move. We want to move the origin back down. What is it? Okay, so for one, we know that, okay, so from our So from RGB to GDT, 0, 0, 0 maps to -1, 0, 0. Alright. 1, 1, 1. Whoops. Maps to 1, 0, 0. Alright. We know this. So we want to add it first, right? We also know that move from one to the other, and then we can just find the we can just like find the inverse, right? Because I don't know. God, it's been so long. Because I the fucked up thing is that I had figured this out already. I just can't remember how to do it because I lost all my notes. Because I didn't do them digitally. I did them all physically in an actual notebook. Because I'm a fucking dumbass. So, what is... Okay. Let's see here. Let's see. I want to have sure, I'll do it in this way. I don't wanna. So Monday. Money? Yo, just fucking do my thing. Oh my god. Oh, okay, well let's do something. Let's do something easy, right? Because something easy would be if we wanted to map 0 to 1 to -1 to 1. We would subtract a half times 2, multiply by 2. Right? Oh, actually, I could just do that, so that I can map. If I do that, then things simplify greatly. Right? If I rebalance the RGB into something, well, let's just say, because we want to make sure that they have the same thing, right? So it would be to go from RGB to GDT. You see, we take we do M times the C minus 0.5. Right? We can do that. So like times 2, right? That's the remap, but we don't necessarily need to do that. We could just do C minus a half. That makes things a lot nicer. Because it's a translation, right? We have a translation. There's a translatory aspect to this whole thing. Right? I think technically speaking the transformation matrix for a 3x3 is for like a 3-dimensional vector is a 4-dimensional vector. Is a 4-dimensional thing. But like it doesn't matter, right? So we have that, which means that to go from GDT to RGB, we write out these, right? So, D to G, T to B. Alright, so the space is, so this is the D to G, the D to G, color space translation is a 4x4. The first vector is what? The first vector, yeah, because we have G, alright, this is the GDTA to RGBA, right? GDTA to RGBA, right? So we know it's a 0, 0, 0, 1, 0, 0, 0. Alright, we already know that. That's easy because it's just an identity matrix, right? Just that section of the identity matrix, right? So what we have is what exactly? We will have okay, yeah. So it's that. So we do just the things with the offset. Yeah. I mean, except for the alpha. Because the alpha is going to be the same. Right. So and this is equal to this what is it, minus 0.5. Right. So actually, this is actually 1/2, right? Something like that, right? I think. I don't know. I'll have to think about it. Yeah, because we want to map -1 to -1/2. So this is actually a 0.5. 0.5. So I mean, we could do alpha, right? We could do GDTA. You do GDTA. So it's all within like the same range, right? Because it's all mapping from -1 to 1. I need coffee. Still need to tell my dad about my streams. I need to do that. So, yeah, GDTA. Especially given the fact that my dad would probably get a huge kick out of this. Let's see. Okay. So we have all of those. Right. What do we have? We have. What is it? So we have the alpha is the same shit. Right. Yeah, and to get the RGBA, you just add 0.5 after it, right? Because we could do. What we can say is instead of this here, we can just say, you know, plus 0.5 is equal to RGBA, right? Because it's all about color space, right? It's all about color space. So we have the 0.5 offset. We need to understand that this is, you know, because we also like multiply the whole thing by 2 or whatever the fuck, you know, whatever the hell it is that you want. Because it's this kind of multiplication, then you add 0.5, then you get this color space. We're converting from one color space to the other color space, and then we just take this and reverse the order, right? So that's fine. So what we could do is, so to get from RGBA, what is red? Red is oh wait, no. We gotcha. So what is gradient in this color space? What is gradient in RGBA? Oh, it's not +5, it's -5. No, it is plus 5. Yeah, this plus 5 equals that. Otherwise, this minus 0.5 is equal to, yeah, okay. Yeah, gotcha. So what is gradient in RGBA minus a half? I mean, it should just be 111, right? Well, A alpha, okay, so minus 1 equals minus a half plus a half equals 0. 1 times a half is equal to what exactly? Okay, so the gradient, grad 0 is half. 111. The fuck am I doing? This is hard for me to fucking reason. What the fuck am I targeting? The RGB minus the half. RGB minus a half. Yeah. The alpha is 1 minus a half is 0.5. So the gradient is 111 minus a half is 0.5. Right? 0.5, 0.5. Okay. What the fuck was D? What did I call D? Because it's a gradient? What is D? Because D is green. D is green. Which means minus 0.5, 0.5 minus 0.5, and temp is, yeah, D is green, so temp is what? I guess this is like exposure. This is like, I don't know how to fucking describe it. Because it's like it's a green-purple scale. Right? It's a green-purple scale. I don't really know how to like fully explain it properly. I don't know. So I could do temperature. Temperature is full red. So 0.5 half green. Alright? Yeah. half green. So 0 minus 0.5. Fuck. Goddamn. Yeah, temperature is red plus half green. Plus half a unit of green. I think that's proper. Pretty sure at least. So we have those, and I think that is correct, which means back to the back to back. That is how you get the that thing, and then yeah, I could just exit out. Oh, decimal. I'm a fucking dumb fuck. Cool. So it is a 0.5. Is it really 0.5? Okay, 0.5, 0.5, 0. This is a minus 0.5, 0.5, minus 0.5, 0. This is 0.5, 0, minus 0.5, 0, 0, 0, 0, 0.5. Yeah, that should be it. And this is a calculator, right? Okay. Lots of halves and ones and shit. So the GDTA to RGBA is equal to that. And the RGBA to GDTA is going to be equal to 0.5 minus 0.5 1 0 right. 1 1 0 0 0.5 minus 0.5 plus 1 0 0 0 0 2. Times RGBA minus 0.5 is equal to yeah. Right. Right? Is that correct? So red is huh? G G is on. Red. So full red would be. What is red? Red would be fucking what? .5 minus a half one. Yeah, that does make sense. Yeah, 0.5 minus a half and 1. 0.5. Yeah, a half minus a half. 1. Alright? So if this is 0.5 minus 0.5 and 1, we have. And alpha doesn't fucking matter. So if we have that, then we have 0.5 times 0.5, that's a quarter. Minus a half times minus a half is a quarter, so we have a half. We have another half, so a half plus a half. A quarter minus negative a quarter plus a half is equal to 1. That equals red. Yeah, okay, cool. Green is, we would expect it to be full. How the fuck is it full bright? It's not full bright though. And it's also not fucking orthogonal either. How is this fucking full bright? It's not. I really don't understand. Is it just truncated hell hard? Like, what the hell is going on? Why is this full bright? I'd expect full green to be half. Full green to be half. I would expect full green to be fully green should be half of the gradient .5 gradient should be 0.5 grade. Like 2/3 grad. Like half grad. Half. It's like 2/3 grad. And but these are orthogonal. So yeah, that is be 0 gradient. But is it? Monday. Fucking hell. Nonde. Oh. Why? What is green? Is green slightly up? That's the real question. Is green lifted? Is pure green actually lifted? Because if it is lifted, right? If we say that pure green is halfway up the gradient, then what would that even look like? Because this makes sense here, right? Like this makes sense right here. This makes sense, but this doesn't. Because red should be 0.5 Nonde. So half green should be fuck. What is temperature? Temperature is 0. Green. D. D is not just straight up green. That's the thing. D is not just straight up green. Green is not 1. This should be 0.5. Which means, yeah, green is orthogonal to temperature, right? We are setting green to be orthogonal to temperature, and alpha, by definition, right? So yeah, green is orthogonal, which means that what we can do, we can say that, oh wait, what? Nande. So we know for a fact that 111 on all of them. Ones on all is ones on all. This is correct. This right here is correct. Green is sunken. Green is sunken. So green is sunken. Green is Monday. Why is this blue? Sure. Seems wrong. Seems very wrong. What? Temperature is halfway between minus a half and a half on green. So that is correct. That is temperature. So then, if that's the case, then where does green land? Green is 1/3? Is it 1/3? 1/3 brightness. Green is 1/3 brightness? Green has 1/3 the brightness? Nani? Eh? Oh! Ah! I am confusion. I am confusion. I'm confusion. So And then 1/3. So green is a third, and magenta is 2/3. Green is 1/3 brightness, magenta is 2/3 brightness. Alright, and they are opposite of one another. Fuck. Yow! Which means D is what is D? So, what is D? What is D exactly? I'm so very confused. Like, I don't know how to translate it back. Like, do I go into here and then convert back? Question mark? Because pure green is going to be 1/3 brightness, 1/3 gradient, all of D, one-third G, %, D, 0T. And I could make it a half, just to make things nice. Alright. Just to make things just a little bit more symmetrical, right? But I think that, because if I do that, then okay. So if I do 0.5, 0.5, oh, sorry. This is actually, come on, 0.5, 1, 0. This is 0. Oh wait. Wait, no, it's minus 0.5. Alright. One, 0, 0. That's a total of 1. That's a total of -1. Okay. The fuck? Two, two, two. Nani? Nani? How the fuck? I don't get it. Yeah. How? Doesn't make any fucking sense. Because all these end up turning to 2. This turns to 1, 2, 1. 0.5, 0.5. 0.5 minus 0.5. 0.5. The fuck? How? I don't fucking get it. Or because I don't understand these matrices. These matrices make no goddamn sense. Because okay. Okay, so what if it's fractional, right? What if it's fractional? Right? What if it's man, how the fuck are these both minus? Nande. Nande. What the fuck? How? Minus a half. I think I'm doing something wrong. So let's take a look at what this is all going to be about. So if we have the color cube and we remap it, we shift RGB that we have. We shift RGB, so if we shift RGB to be between minus 0.5 to 0.5, right? Minus a half to a half, right? And that means we subtract a half from that. Which means what? Red is 0 alpha. Red is Red is 0 alpha. It is what? Yeah, red is 0 alpha. It is how much temperature? So we know that, we have alright, we're looking at it from this side, right? This is red, this is blue, this is green. We have this right here. We have this here. We have that here. There. 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 And this. So this is by definition alright. And from the side, red is over here. Alright, so red is over here. And it is also fucking yeah, yeah, this and this. This is also 1, 2, 3. This is 1/2. So from the side, we know that red, right? This is 0. So it's minus a third. So we know that the it's gonna be that, right? So we know that red is going to be minus 1/3, right? We know that it's going to be minus a third on, yeah, all of them are going to be minus a third. Every last one is minus a third, right? And 0. We know that. For the gradient. So red is, for temperature, red is full temp. Blue is minus temp. And this is minus 1/2. This is minus a half. Right? This is also 0, this is also 0. This is also 0, this is also 0. And we're just gonna say that that's 1. We can change what these actually mean later, right? Because we can renormalize. Right? So we have that. What's going on here? So we know. Okay, so we have that, we have that. So we have these two done. Cool. Cool. Which means this is 1, this is 0. We know that this is the case. This is the proper matrix. And this is multiplied by RGBA minus 0 multiplied by RGBA minus half. Right. Alright, and then this is G dt a times 1/2, right? Something like that, right? Something along those lines. So we could multiply this whole thing by 2, or divide this whole thing by 2. Multiply this whole thing by 2. Yeah, divide it all by 1/2, so multiply it all by 2. Multiply this whole thing by 2, and we can just subtract 1/2, right? And then I'll normalize everything. So, what the fuck, right? So -1, 2. So that becomes, if we're gonna do that, then that means it becomes what? -2/3 -1, so it's -2/3 -1 2 0 -2/3 2 0 0 -2/3 -1 -2 -2 0 and 0 0 0 whole. There's this times RGBA -1/2 is equal to G E E A gradient exposure, oh, x GXT, gradient exposure temperature alpha is equal to, right, and alpha is normalized between -1 and 1, which means that the inverse of this is equal to, and I think that's correct. So and then we can also renormalize it afterwards. So let's do a -2/3 -2/3 -2/3 0 0 0 0 0 0 2 2 -2 2 -1 -1 yeah, very strange looking. That's a crazy weird shit. Not gonna lie. Yeah. It's like a transpose and then divided by 2 kind of thing. how are all those on the middle? How's it all in the middle? How's it all in the middle? I don't know. I mean, I guess I could. What? Nande? Ah, right. Yeah, you find the pivot and you just move it. So we move those down and then. Yeah, because we can swap rows just fine and it's like fine, it all comes out the same. Mm-hmm. Yeah, I forgot how to do all that shit. Yeah, the augments and all that, so let's do some more shit. So it is minus 1/2 minus 1/2 minus 1/2. Nande. Nande, nande, nande. Nande. Okay. Minus a 6, a third, minus a 6th, 0, 1/4. That's not a 4. 0 minus 1/4. 0. 0. 0. 0. 1/2. Alright. Yow! Fuck. So how? What the fuck? How is that a thing? Alright. I'm doing this shit right? I don't know. GXT. I feel like I'm doing something wrong. Alright? Like, fuck. So, if I do GXT, okay. So this is multiplied by G, X, E, A. Should be plus 1/2. Plus 1/2 is equal to R G B A. So what is pure gradient? just gradient. So 1, 0, 0, 1. 1, 0, 0, 1. Minus a half, minus a half, minus a half. What? That equals minus 1. That's not correct. Pure gradient. Oh. What? No wonder. The whole fucking thing. What? So does like the whole thing need to be divided by 2? But it's already divided by 2. What? Nani? Eh? Yeah, the whole thing is divided by 2. The G needs to be positive. Alright. So pure G. 1, 1, 1. Alright, let's start mapping these out, alright? We have 1, 1, 1. Maps to actually 1, 0, 0. 1, 0, 0, maps to minus 1, minus 1, minus 1. Alpha is fine. So 0, 1, 0 maps to what? X maps to minus 6, minus 6, minus 6 plus minus 6 is 2 6, which is 1/3 minus 1/3 plus 1/3 is equal to 0 plus a half is equal to 0, 1/2. That's not correct. Temperature. Oh, I know we did this wrong. G is 0. What? I did this math wrong. It's not that. It is literally just RGB is just G is just 1 1 1 1. Is this backwards? I think I'm doing this backwards. Okay. Yeah. Because if I do that mapping, this is the incorrect mapping. The fuck? Which means... Okay. So, let's do... GXTA. Some matrix M. Some magic matrix M. Times GXTA plus 1/2 is equal to R G B A. Okay? So, what goes in here? So we know that if this is G, right? One, two, three. If it's just G, then what is R? Right. If G is the only thing that we're dealing with, then if G is 1, right, if G is 1, then we know that it's going to be a third plus a third plus a third, or a sixth plus a sixth plus a sixth, which is a half. Right, so that's 1 6th, 1 6th, 1 6th, 0. Right, we know that it is a sixth plus a sixth plus a sixth is a half. Plus a half is equal to 1. Because if this is minus 1, it's minus a sixth, minus a sixth, minus a sixth, which is minus a half. Plus a half is 0. Wait, this is incorrect. What? The fuck am I doing wrong? G is, if it's just G, it is minus a half plus a half. Oh no, this is just a half plus a half, half. I'm not adding these. I'm just saying, when G is 1, I know that the answer, if G is 1, it is 1 0 0 0. It is 1 0 0 0. We want 1 1 1 0. Which is 1/2. 1/2. 1/2. If exposure is 1, which is this node here, which is over here. Well, actually, it's over here, right? It is exposure, right? We're kind of like filling these things out, right? Kind of moving these these things out a little bit, right? So it is going to be exposure. If exposure, right? If exposure is 1, then we want. Well, I mean, I guess it could just be minus grain. Because it makes. I don't know, just magenta seems more negative to me. Right? Like, I don't know how to explain it. Like, I don't know how to describe it. So 100% green, 1/3 red, 1/3 blue. Nande? Honey? If exposure is we know that green is going to be 1/2. Cool. What about red and blue? We know that alpha is going to be 0. What about red and blue? What is red and blue? That is 1/2, and what is red and blue? Oh, fuck. If it's just exposure, what is red and blue? Zero? Zero red, 0 blue? Or is it 1/3? Or is it like a 1/6, right? Or is it a 1/6? Right? Because I'm thinking that it should be. So. Right? Or is it is lifted a little bit? Right? Because it is green up here. Because it is, you know, like all the way up here, which means that it is technically right here. Means it's what, a 1/2? A 1/4? A 1/3? Because it is lifted, right? Because it's like this point right here. Because we want to do a little bit here, a little bit here to lift this up, and that will bring it in a little bit too, right? Because like this is like a whole, you know, thing here. So like these metrics are things that will change, right? We could also think about like here we have the idea of GXT, GXTA. Like what does that equate to when we're talking about it, when we're looking at it? Is it actually a third? Is it 1/2? Is it actually a third? Right? But there's kind of a lot going on here. Because like here we know for a fact that this is 0. Right, we know for a fact that this is a half. Right? We know that to be true. Alright. I mean, I guess. Okay, so let's take a look at temperature. What happens at temperature? If temperature is all the way 1, where is that in the color space, right? Well, let's take a look at alpha. Alpha is just a half. That's a 0. A 0. That's a 0. So if temperature is 1, what does that mean in RGB space? What color is temperature 1? The color should be all red, half green, right? Because, you know, it is all red. And then this is half green, right? Because this is the green direction. Cool. So it is, so blue is minus a half. Minus a half plus should be half green, which means 0 green. Half red. This is the spread. This is correct. Cool. We have that. We have that. Exposure is a colossal fucking pain in the goddamn ass. Where is exposure? Exposure's on the halfway point. So are we looking at the intersection? Because exposure is right here along this plane. Which means green, and then that, and then that. So if we have this, right? You know that this is the origin. This way is plus x. This way is minus exposure. Right? We have this here. We want to draw a plane here. This is 1. This is minus 1. Right? Which means it's this intersection. I don't think that's accurate. I actually think it's like this actually. It's actually like a third. Because it should be half. What is half? Minus a half plus a third is minus a sixth. And then I think that's correct. So a half, a half, a half, a half. Minus hello. Fucking cool. Hello, hello. Sorry, I was just focused on a bunch of other stuff. I don't know how long you've been there. My bad. Oh, and you're also on YouTube. Well, bye. Hello, goodbye. Now, if you are gonna go, then sorry for accidentally ignoring you. That was not my intent. How do I invert the matrix again? How do I invert a matrix? Hopefully you weren't there for too terribly long. If you were, then my bad. So how the fuck do you invert a matrix? How do you invert a matrix? Because like I remember the how do you invert a matrix? How to invert a matrix? Yeah, because there's like the whole determinant yada 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 blah blah blah. But with the I don't want the damn. What is it? I was like just looking at it. I was just looking at it. What was it? Now I feel bad. Oh well. What did yeah, by hand. How do you invert it by hand? Yeah, the augmented matrix. Yeah, how do you do the augment? All that stuff. You do that, you what? That doesn't make any damn sense. Yeah, how do you use the augment? How? Yeah, okay. So I do that. Okay, so the operations are okay, so if I have this, right? So let's see here, right? So half, 0. So 1 half, 1 half, 1 half, 0. And then minus 6 to half, minus a sixth, 0. Minus 1 sixth, 1 half, minus sixth, 0. Half, 0, minus a half. 1 half, 0, minus 1 half. Right? 0, 0, 0, 0, 1 half. And then here we do an augment of 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, and we close it off. So how do we use this, right? So what is it that we're actually doing here? That is the question. So how do we use this? The main thing is that we can multiply a row by a non-zero scalar. Anything by not 1 and not 0. We can add a row to another. We can add one row to another row. And we can replace a row with, we can just add in place a row to another row. Right, so the valid operations are times equals scalar r I plus equals s r j and r I r j. These are the three valid things that you can do, right? So, right, times equals, we can do I plus equals, right? These are the three things we can do. And we want to make this look like this, right? That's how you invert a matrix, right? So what you can do here is, because I'm like not super pleased with how everything is working, so because all I want to do is I want to subtract a half and then multiply it by matrix, and if and boom, Bob's John. Okay. That's pretty much like how I want things to be. So one of the things we could do is figure out what exactly. So one of the things we could do is figure out what this line is going to be. All right. I guess I could so what is the whole thing going to be? It's going to be That's something I feel like I should do. I feel like I should have a thing saying, hey, go to either YouTube or Twitch on the title bar. I feel like I should do that. Anyway, some other time. Or have like a ticker or something up at the top. Ooh, I think I like that idea. A ticker. And just use the same shade. I'll probably deal with that off screen, off camera, off stream. So, what is this whole situation going to be? So I have that, which means what exactly? Which means if I multiply, right? If I multiply by 2. I have 1 minus a third 1 0 2 0 0 0 1 half 1 half. I mean, I don't like fucking any of this shit. So let's do something a little bit different, right? Let's do this in something else, right? And some more coffee. Okay. Stop. So let's go into that. Let's go into oh, 1032? 1030? Okay. And that's gonna be that. Good to know, good to know. Alright, so let's do let's go into yeah, let's do a notes.md and enter it. So we have a no, I can do. So it is what? 1 on 2. Minus 1 on 6. 1 on 2. 0. All right. Well. One. Okay. And then we do oh, actually I think I should do that. Actually. There we go. There we go. Well, I mean, because I want it, like, I want it to be like a literal. I want it to be a literal thing, right? I just want it to be a literal yada yada yada, etc. Alright, so I can do that. Alright. So in here we have 1 half. 1 half. What is that? Game's done quick? Okay. 0, 0, 0, 1. Oh, actually, these are all zeros. Then we have another 1 on 2. 1 over 2 minus 1, 6. Alright, yeah. Minus 1 half right? God, fucking goddamn it, dude. Right. Zero, 0, 1, 0. Okay. 0, 0, 0. 1 half. 0, 0, 0. Okay. So, what the oh my god. Okay. So, what's gonna go on here? So if we have these, then so we can add, we can, yeah, there we go. We gotta have those. All right. So we have, we can multiply equal. So we can set this to be 1 minus 1/3, 1, and since we multiplied it by 2, we could do that, right? And then we yeah. Yeah, you go column by column. Inverting matrix using the augment. Gauss-Jordan elimination method, so swap rows, multiply, divide a row, add, subtract rows. Yeah, so you do it to the entire row. So right, because what I can do is I can subtract, like technically speaking, I can subtract half of this row. Like I can subtract this row from this row. 1/2 plus a 1/6. Right, I can subtract this row from, I can subtract this row from this row. So I can go 0. 1/2 plus a 1/6 is 4/6, 2/3. Right, so this is 2/3. 1/2. Since I'm subtracting 4 from 3, well, I mean 3 from 2. Alright, just line 4 from... I'm subtracting line 4 from line 3. So that means I'm getting... This is going to be -1. Right. Now, I want to subtract half of line 2 from line 4. Subtract half of line 2 from line 4. This is a 0. This is a 0. This is subtracting half of that from half of that is that. Right. Half of 1 from 3. Right. Half of 1 from 3. So subtract half of 1 from 3. This is a -1, 0, 0, 0. Okay, cool. Alright, yeah. And then just do a little bit cleanup. Okay. Okay, cool. So I have that. You have some other obligations. There we go. Let's see here. Cool. Next one. We want to multiply it by 3 divided by 2. So 3 halves. 3 halves of this. This is by definition 1. 3 divided by 2. 3 quarters. 3 quarters. 3 divided by 2. Minus 3 divided by 2. Yeah. Okay. And then I add a third of 2. I add 1/3 of 2 to here. So that is by definition 0. A third of 3 quarters is a quarter. I'm adding a third of 2 to 1. So 4 5/4. That's not what I fucking wanted. Thank you very much. Five fourths. Add a third of 2 to 1. Okay. A third of that is 1/2, so I add a half. 1, 2. What? Shit. Fuck. I didn't save. And I don't know how to go back into it. Alright, whoops. I fucked up. I fucked up. Okay. That's cool. I don't want that. Okay, it's actually pretty close. Okay. 1/2. So I have that 1/2. I'm adding a third of one to the other. I'm adding a third of one to the other. So minus 1/2. Okay. Okay. That's good. That's good. Cool. Step 2. Step, 30,000. So, just make all this. Yeah. Right. So I can't add these two together. Right. I pretty much have to use this one because of these leading zeros. So I want to subtract 3/4 of this from that. So if I subtract 3/4 Okay. Time to bust out the calculator. Do I have a calculator on here? Oh, I do. Okay, so it is 3 on 4 minus. Oh, wait, 5 on 4 minus. Oh, actually, okay. Yeah, let's get rid of that. So that is R0. Well, actually, R0. Alright, I can do that. So minus 3/4. The calculator is 3 divided by 2 minus 3 divided by 4 is 3/4. Okay. R is 4. Oh wait. Okay. So here I'm subtracting 3/4 of this one from this one. So I don't need to touch this. I need to add 3/4 to that, which means that's a 4. And then this is minus 3/4. I can do that just to separate these out a little bit more. Okay. Okay, cool. I got that. Now I need to subtract 5/4 of this one from this one. So that is by definition. That is by definition a 0. Okay. 5/4 of 4 from 2. 5/4 of calculator. What is that? 2 minus 5 on 4 is equal to 3/4. Okay. So 3 divided by 4. 1/2 plus 5/4. 1.75. Okay. So 7/4. Yeah. What? This doesn't make any sense. I'm very confused. Okay. Let's Reddit. 2. Is that correct? That does not seem right. Like at all. It seems very strange. This doesn't quite seem right. Because the top should all be the same. I feel like the top should all be the same. Alright, so that should be 1/2. 1/2. 1/2. 0. This is a 1/2. Right? Yeah. 0, 0. I'm convinced I'm doing something wrong. I'm sure I'm doing something wrong. I mean, I used to do like inverse matrices in like my head and shit. What is this, a non-invertible matrix or some shit? It should be invertible. It's not fucking calculating. What the fuck do you mean the site can't be reached? I'm gonna fucking lose my goddamn mind. Yeah, okay, so I did... Okay, so it is 3/4, 1/2, 3/4, not 7 fucking quarters. And 1, 0, -1, 2. Okay. So This is a 3. So I did do it correctly. Almost. Did it correctly. Mostly correct. So that makes more sense. This part here makes a lot more fucking sense to me. With just how these things operate, right? Yeah. So, alright. So, ¿por qué? So is it this one? Yeah, it should be this one, right? Times pix minus a half. Oh shit. I am terrible. 0.5. Right? And then it is 3/4, 1/2, 3/4. Well, 0.50 0 0.00. Why am I doing it this way? Because then everything's all lined up properly. Alright, because I can also go 0.00, and I can even go 0.00 here, 0.00 here, 0.00 here, right? This is not what I fucking wanted. Yeah, I mean, it's fine. They're like, R? Oh, yeah, I can just go into, like, replace mode and shit, right? You know, because I can just do that replaced with shit. No. So, what is it? Minus 3/4, 3/2, minus 3/4. Minus 0.75. Zero 1.50. Right. I think that's correct. Oh no, it's minus. Oh, okay. And that's not a 4, that's a 5. Okay. And then the next one is 1 0 minus 1 0. 1, 0, minus 1, 0. 0, minus 1 point, 0, 0.00. And then the last one is 1, minus 1, 0. Yeah. And then this one is that should be it. And then color times 2. Well, it's color divided by 2 plus a half. Or color plus 1 on all over 2. Right. Alright. Color plus 1.0 divided by 2.0. Right. Or I should say times 0.5 is actually better. You don't want to do division unless you absolutely have to. Like if the inverse is known at right time, like if you can just calculate what the inverse is, you want to multiply by the inverse. Multiplying by floats is a lot faster than dividing by floats. Floating point division is a colossal fucking pain in the ass. It sucks. It sucks so hard. So yeah. So I almost did it right. So yeah. Is this gonna be... Is this gonna work? What? Nande? Nanda, nanda, nanda. I'm doing something wrong. I'm doing something very, very wrong. So... Fuck my ass, dude. I mean, I'm at like almost 3.5 hours. Yeah, I think I'm gonna go. I'm kind of running out of steam. Anyway, fucked up and missed my first YouTube comment. Oh well, my first YouTube chatter. That sucks. Sorry, Keegan. I'm a terrible, awful streamer. I'm bad. But I mean, I guess it is what it is. Oh well, shit happens. I mean, I missed my first raid, so that makes you feel any better. Not just you. It's like literally everyone. Yeah, whatever. So I guess that's gonna be it. I'm kind of running out of steam, so I had a lot more energy this time. Definitely a lot more energy this time, which is good. I'm definitely liking the split streams. I think should do more streaming stuff. I still need to figure out what the fuck I'm doing wrong. Something just isn't. Something just ain't right here, boy. Something just ain't right. So, yeah. Yep. I don't know, white, black, green, magenta. I think I want to do white, black, green, magenta, red, cyan, blue, yellow. Something like that. I don't know. I'll figure it out. I mean, or I could do green, yellow, red. Cyan, blue, magenta. I don't know if I like that either. Because, like, cyan and blue is super close. And then, like, white, black. Something like that. I don't know. I'll figure out some fucking color bullshit at some point. Make it a little bit easier for me to actually figure out what the hell is going on. Because I know for a fact that I'm fucking something up. Right? Like, something is incorrect here. Something is not right. And it's like really difficult to figure out the color space. I might end up just writing because white should be white. White is white. You know? I don't know why it's not doing shit properly. Yeah, white is white. White is white. White's white. Why is white is white? Why is that not? White is white. So, ¿por qué? ¿Dónde? White is white. Yo, like, what's going on here? Yeah, I don't understand it. But anyway, okay, fuck. Yeah, I don't know why that got all fucked up. Because that left-hand side, it should translate fully here. I'm there. White though. White and that's black. Like, this is white, this is black. Nande. Why? ¿Por qué? ¿Por qué no trabajo, mi amigo? ¿Por qué no trabajo? ¿Por qué? ¿Por qué? ¿Por qué? ¿Por qué? ¿Por qué no trabajo? Fucking ¿dónde? ¿Dónde? Scheiße. Qu'est-ce que c'est? Alright, yeah.